Okay, guys, today what we're going to do is we're going to begin our look at the next type of graph that we're going to be creating. Remember that we've been working with linear equations where everything was a straight line. Well, today what we're going to do is we're going to begin our look at something called parabolas. Okay? And parabolas are created from a completely different type of equation. Okay, so let's take a look at that equation first. So if you have some equation, x plus b equals c, notice there is no exponent on the x. Let me write that a little further. And that's how you know that it is definitely going to be linear. Okay. Well, today what we're going to do is we're going to look at equations where you have an exponent on one of the x terms. Okay. So, but in order to be a parabola, that highest exponent will be a 2. Okay, so you're going to have x squared in your equation. Now, sometimes it's a little harder to tell that it's x squared because it may be in what's called factored form, something that looks like this. But think about if you took this x times this x, which is what that means to have one bracket next to another bracket like that. If you took that x times that x, it would give you an x squared. Okay, now, we are again going to work just like we did when we began graphing linear equations. We're going to begin our work with a chart. Remember that our chart had some x values, and we plugged in those x values to get y values. And it doesn't matter what values you use, any values will work. Now, in the homework that we're going to have, they're going to give you some values, and you're going to just plug them in. So that's what we want to look at first. So let's just go to the book and see what they do and work some of the examples that they've given us. Okay, so here we are. Let's see if I can make that larger. There we go. So here we go. So basic parabolas, and there again, they're talking about the same thing I did. And a parabola, again, is given a shape from what's called a quadratic equation where the highest exponent is a 2. Okay, so let's take a quick look at what those do. A parabola is always this U shape. Okay, with a soft curve at the bottom. Okay, now it can open downward, upward. It can even open sideways, but we're not there yet. They can be very wide or they can be very narrow. But they always maintain that same U shape. Okay? So all parabolas are this shape. Or they can be turned upside down and stretched. Stretched means to get wider, right? Or they can be any combination of these. So it can be upside down and very wide. Okay? So, but anytime you see that U shape, you have what's called a parabola, so you know it's the graph of a quadratic equation. Okay? Now again, they are recommending, and for the first set of exercises we're going to do, you're going to be using a chart. But as we use that chart, we're also going to be looking ahead and seeing some things that different parts of an equation, the effects that different parts of an equation have on a parabola. Some things are going to make it move up and down. Some things are going to make it wider or narrower. And we're going to learn about how and why those things have that effect. Okay? So, the first one that you have here is the graph of a basic parabola. And you'll see they've given you the equation of y equals x squared. And they've given you some values and filled them in. So what they did was they took the 3, put it in place of the x, and then we did the math. So y equals 3 squared, and of course 3 squared is 9. Y equals 2 squared, which gives you 4, right? Y equals 1 squared, so that gives you 1. Y equals -1 squared, and that's why you have to put it in a bracket, because otherwise you would have this, which is not the same thing. Anytime you replace a letter with a bracket, with a number, you have to put it in a bracket. So that literally means -1 times -1, which becomes a +1. Watch your signs, use brackets, okay? So that's that point. And they just continued on, -3, -9. And then they've plotted those points. 3, 9 means to the right 3, up 9, 2, 4, it's right there. 1, 1, right 1, up 1. 0, 0 is the origin. -1, 1, -1, 1, etc. And if you'll notice these points, what I want you to see about them is that they are a mirror image. So if it's +3, you get 9, and if it's -3, you get 9. If it's +2, you get 4, and if it's -2, you get 4. So this side of the parabola is a mirror image of that side. And this one is called the parent graph. And the reason for that is there's nothing else in there but y and y equals x squared. And it will always give you this exact shape. Okay? And if you'll notice, it's always 1, 1, 2, 4. So it's squaring. So 3, 9, right? So you always get just the squares. So if you did 5, you'd get 25, right? Because that's all the math we have available to us there. Okay. Now, they don't always stay that way, though, because we can have other quadratic equations. So we can have y equals x squared plus 1, for example. Okay. So you see this one has something else added to the x squared. It'll still make the same shape, but it's going to change the numbers that you get for your y, which is going to change the position of the parabola on your graph. Now again, we're just going to concentrate on plotting numbers right now so that you can get to, until you get used to this. But later, we're going to look at how you can just use this piece of information and know what it's going to do to that parent graph. Okay? So, here we go. Let's look at some more. Okay? So what we're going to talk about is something called translated parabolas. Okay? Translating a parabola just means that you're moving it. Okay? And so, as a matter of fact, you'll see they use the same one I just used for an example. It's a classic example. So they've given you your chart. It's 3. So if x is 3, y equals 3 squared plus 1. So 9 plus 1, which is 10. Right? So what happens is that every time you square the number, then you're going to add a 1 to it. All right? And if you look at the graph of it, you'll notice that now, instead of starting here at 0, 0, the graph begins up 1. So this +1 part is telling you that the graph is moving up 1 from the origin. Okay? So it's moving it up 1. So what do you think x squared minus 2 would do? You'd still get the same exact parabola, the squaring one. All the values would be 2 less, which means that it would start down here and then go up. So it would start down 2. So that's what that -1 is telling you. Now, you're still going to fill out the chart. You're still going to plot the points and then draw your parabola from there. But you can have some idea of what the graph is going to look like before you even begin. So let's look at some more. Unfortunately, I copied these backwards, so we've got to go up to get to where we need to go. So here are your exercises. Let's just do number 2 for you. And we're going to create the chart, and then we're going to plot them. Now, they don't give you a different graph on this. They want you to just draw the graph on the same equation, on the same, draw the graph of each one on the same graph here, but you'll get it. So here you go. They're showing you x squared minus 2. I keep using the same examples. So see, it just give you the same parabola, except it starts down here at -2, right? And where you would have gotten 3 squared equals 9, this would be 9 minus 2, which gives you 7. So it's very easy to see what's going to happen to the numbers when you have a graph like this. Okay? So again, let's just look at some examples. We'll do the first one. Now I already know from looking at it, y equals x squared plus 3, I know that it's going to start right here, up 3. Now, you still have to figure out the rest of the points to be able to know what it's doing the rest everywhere else, but you know that it's going to start up 3. Now again, be careful. There's no number in front. If you have y equals 3x squared plus 3, that's not the same thing. It has to be just this plain x squared part, okay? We'll learn how to deal with the rest of it later. Now, let's just finish the chart for it. Again, now I'm not going to write them all down, but I'll write the first one down. We have y equals, our first number we want to test is 3. So x to the third plus 3. So 3 squared is 9, plus 3 gives us a 12. Now we're just going to do it. I'm just going to talk you through it. If you square 2, you get a 4, and add 3 to it, you get a 7. Square 1, you get a 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. -1 squared is 1, plus 3 is 4. Now, I don't even have to do the rest of them because we know that since it's absolutely symmetrical, a mirror image, that once I get past 0 and start doing these negative numbers, they're going to give me exactly the same numbers as I got from their positive values. They have to, okay? It's always going to be that way. So let's plot those points. We have 3, 12. So that's to the right 3 and then up 12. We have 2, 7. So that's to the right 2 and up 7. We have 1, 4 to the right 1, up 4. Then same thing, but on the other side, -1, 4, -2, 7, -3, 12. And you'll see that it makes a nice, smooth parabola. Okay, that's a mirror image on both sides. Okay, now you do the same thing with the other one, and you'll just plot it on this same graph. Well, having a number at the end like this is always going to simply move the graph either up or down that many units. Again, as long as that x squared is all by itself. But let's look at what happens when we have a factored form of it. And you always know it's a factored form because you'll have brackets. That's how you can tell it's been factored for you. So let's look at what happens to one of those. There's all your homework. And this is the last one we'll do, guys, for this thing. So in this one, what we're going to get, the other translation was called a vertical translation because it moved it up and down. This time, we're going to have what's called a horizontal translation because it's going to move it either right or left. Now you have to be a little more careful with this one, because with the vertical translations, going up a positive 3 plus 3 would make it move up 3. Negative 2 would make it move down 2. But you have to remember that with these, when you get the translations, because they're in their factored form, they're linear, they look linear, then what's going to happen is it's going to move it right or left, but if it looks positive, right, like a positive 1, it's actually going to move it to the left 1. And that's easily explained if you just think about what's happening here. What we're really doing is setting the equation equal to 0 and then solving it by doing the opposite. And so anytime you take a number away from an x, it always changes its sign, right? Do you remember that? So if you had x plus 2 equals 0, you would subtract the 2 from both sides. The 2's would subtract away on that side, and it becomes a negative 2. And so if we pull that number away from its x, it's going to change its sign, okay? And so that means you're going to have to work on your table a little bit, or work on your translations a bit, so you'll know that that goes either to the left or to the right. Now, and it's the opposite of the way the sign looks. So here we go, we have our chart. It's x plus 1 squared. So what they did was simply x plus 1 squared means take your number, add 1 to it, and then square it. So that becomes 4 squared, which is how they got the 16. So 2 plus 1 is 3 squared gives you 9. 1 plus 1 is 2 squared gives you 4. 0 plus 1 is 1 squared gives you 1, etc. Now, they extended the table. Let's see why they did that in just a moment, okay? And they did it just to give you another value over here on to the right so that you can see what it's really doing up here. So if you just plotted this part of the graph that they on the plot points they gave you, you would get 316, which is this one. Oops, no, it's not. It's way up here off the graph. So it's really a worthless point for you. 29, that's that one. Okay, 1, 4 is that one. 0, 1 is there. Negative 1, 0 is there. Negative 2, 1 is there. And negative 3, 4 is there. And you'll see they didn't have any points up here to make a nice smooth curve. Now, I think that's fine because you would be able to tell that it's just going up in this direction the same exact way as it's doing over here. That's fine. But they went ahead and got one more point to mirror this one. But you don't have to, okay? If you can usually see what the equation is doing. If you had that point, you know that from up there it's just going to go in a nice smooth curve straight up, just like it did on this side. Okay? So you don't have to extend the graph like they did, but you could, or the table, I'm sorry. All right? Now, notice that it's not on the turning point is not on the y-axis anymore. It's moved to the left exactly 1 point. Let me just do it as a different color so you can see where it is. It's right there, which is negative 1, 0. So it's moved over 1 space to the left. Well, I knew that was going to happen because it's x plus 1. If it's x plus 1, the vertex, or that turning point, is going to go to the left 1. If it's x minus 1, it's going to go to the right 1. And you're just going to have to memorize that fact, that horizontal translations go in the opposite way of the sign that they have. So if it's a plus 1, it's going to go left 1. If it's a minus 1, it's going to go right 1. Okay, so let's look at another one. Let's just go to your homework because these don't really change that much. So you see here we have x minus 2. So that means that the turning point is going to move over to the left 2. Okay, now if we had plus 3 on the end of it, it would go over there and up here. But right now we'll leave that for next time. Sorry, I can't resist. All right. So let's just look at one of the ones in your homework. Okay. First of all, they give you this one, y equals x squared plus 5. Well, that's x squared plus 5. Since you don't have the parentheses, it's not a horizontal translation, but vertical, meaning up and down. Okay? And so this starting point for this particular one is going to be here at where x equals 5. I'm sorry, y equals 5. Okay? So here we go. So if you square 3, I'll just do the first one, I'll write it out, and then after that, I'm simply going to talk you through it. 3 squared is 9, plus 5 is 14, right? 2 squared is 4, plus 5 is 9. 1 squared is 1, plus 5 is 6. 0 squared is 0, plus 5 is 5. Negative 1 squared is 1, plus 5 is 6. And I don't need to do the rest of them because they're simply giving me the negative values of values I've already chosen. So it's just going to start repeating them. Okay? Now, we've already plotted 0, 5. It's right there. 314 is over 3, up 14. So right there. 2, 9, 2, up 9. 1, 6, to the right, 1, up 6. Then it's just going to do exactly the same thing on the other side. So negative 1, 6. Negative 2, 9. Negative 3, 14. And you can draw your parabola. Don't make this a point. Not pointed. Curved. Okay? So make sure you always do it carefully. All right? Now, that's one of those. It's another one of those. Okay, so all of those so far have been just, oops. I did that. All of those are just vertical translations. Let's go to the next page to see if we can't find a horizontal one for you. Here we go. Here's a horizontal translation. Be careful though, because it's 3 minus x. Okay? Oh, I don't like them right now. So, okay, so this one is a little odd. Think about it very carefully when you're doing this. Don't just pull that 3 away and think you got it. It's the same as 3 minus x equals 0. So if you add x to both sides to get the 3 by itself, it stays a positive 3. So this one is going to translate 3 to the right, even though that's a positive 3. And that the reason for it is that's a negative x. So just always take it off to the side, set it equal to 0, and solve it to find out where the translation is going to be. Okay? Now in this case, they're letting you choose your own numbers. The only number that I insist you use is 0, and then it doesn't really matter what else you use, but use some positives and some negatives. And they don't have to be in order like that. I just like them to be because I like to use small numbers, and it's usually plenty. It might